This video is about dimensional analysis. It corresponds to section 2.2 of the Applied Analog Electronics textbook. Now, dimensional analysis is just a very fancy word for using units. And the idea is very simple. What we want to do is anytime that we have any sort of number that corresponds to a measurement or anything that has units, like we might have 2 volts or 3.2 milliamps or 6 ohms or 10 kilopascals, anything like that. We want to make sure that we keep the unit with the number at all times. You do not ever want to write 2 and say, oh, that's a voltage, because it isn't. If you write 2 and it's supposed to be a voltage, you're just wrong. You haven't said the units. And the units are an essential part of the number. You never want to leave the numbers out. Okay, what does this buy you? I mean, it's extra trouble to keep track of the units at all times. Your calculator doesn't usually have units on it, so you're sitting there typing in numbers in the calculator and blindly going ahead, adding and subtracting and multiplying and dividing. And what does it all mean? Well, if you keep track of units at all times, you can use 2 simple sanity checks. When you multiply units, they just multiply. So if we have 2 volts times 3.2 milliamps, we're going to get 6.4 millivolt amps, which you can also write as 6.4 milliwatts. Having this gives you a sanity check in that when you're done with all your calculations, you can check to make sure that the units you've got are appropriate for what you're supposed to be computing. If I was trying to compute power here and I end up with watts or milliwatts, things look good. If I was trying to compute resistance, something's wrong here because watts aren't the unit for resistance. And so by keeping track of what I was doing, I can help debug the error. If I was trying to get resistance, then I should have done 2 volts divided by 3.2 milliamps, because then I would get something in kiloohms, whatever 2 divided by 3.2 is. And that check, should I be multiplying or dividing, is much easier to do if you keep the units around. If you just do 2 times 3.2 or 2 divided by 3.2, you've got no idea whether you've done the right calculation or not. Okay, so multiplying units and keeping track of them the whole way is one advantage. The other one is you can only add identical units. That doesn't just mean that they're measuring the same type of thing. They have to be identical for you to be able to add the numbers. So if I am measuring lengths, I might have them in inches. I might have them in centimeters. I can't add inches and centimeters. I have to convert one of them. So let's say I had something that was, well, I've got a 3-inch piece of metal or something, and I'm going to be adding a 2.7 millimeter coating or something on it. I can't do that addition. But if I do 3 inches times 25.4 millimeters per inch plus 2.7 millimeters, that I can do, because now the inches divided by inches, those cancel, and I'm left with 3 times 25.4 millimeters plus 2.7 millimeters, and those can be added. So you only add identical units. That's a very important sanity check. And again, if you didn't keep the units around, you said, I have 3 and I have 2.7, numbers you can add, but it doesn't mean anything. There is one other thing you want to watch out for, and that is if you're doing something weird with the numbers, like you're taking log of something or something to the 2.7 power or something like that, the thing that you're taking inside here should be unitless. so that you don't take the log of a voltage. You can take one voltage divided by another voltage, take that ratio, and take the log of it. Same thing as if you're taking a non-integer power here, you want to make sure that the thing you're taking the power of is unitless. And that's a good sanity check to do whenever you're taking any of these sorts of computations. And it's really, really easy to forget that when you're doing calculations with just numbers. When you've got the units in front of you at every step, you can find mistakes like, oh, this is millimeters and inches, or millimeters and centimeters even. You can't add millimeters and centimeters. You have to convert both to centimeters or both to millimeters. And making sure that you do those conversions is a really, really important engineering habit to get into. It's not ever dropping the units and just calculating with numbers. Numbers have got to always have units with them, unless the units have canceled out and you've got something unitless as a result of doing volts divided by volts or amps divided by amps, something that actually does cancel the units out completely. Okay, that's really probably all there is to dimensional analysis, just sort of three simple rules. Multiply the units, only add things that have identical units, and only take logs or non-integer powers of things that are unitless.